Hi there. In this lecture, we're going to continue coding with Spark. Here I'm in my Eclipse environment, and I've already, as I explained earlier, downloaded all of the source code for this course. So I encourage you to do the same. It's available on the GitHub repository, and I've provided instructions on how to get that code. So I've opened up Eclipse, and I'm going to import that project into Eclipse. And the way to do that is you right-click and go to New, Java Project, and the project name, this is important, the project name is going to be exactly the same as the project name that you downloaded from GitHub. So that project name is called Project 2 for this lecture. So make sure you get the same one and then just hit finish. And this is saying it requires compliance level 9 or above. You may or may not see this, but basically what it's asking us to do is making sure that we are using the right execution environment. So I've already set this up to run on Java version 8. Okay, and the way you could do that is if you right click, go to build path, configure build path, make sure under the library section you're using the version of Java JDK 8 that you downloaded. Okay, and you can change this. If it shows something else, you can go to edit and choose the Java runtime environment that you have available on your machine. Okay, so mine is using Java 8, as you can see right there. So make sure, again, the code, all of the code in this course needs to be running with Java 8. So make sure you have that correct version. But anyway, in the source main Java folder, I have a package com.javareadyprogrammer.spark. So let's open up our main application class, which is it contains the main method. And here I'm making references to other objects, okay, other classes that I've already created here. So we're going to go over the first example. Let me just comment out these two examples here. We're just going to deal with this first example. So I'm creating an instance of this infer CSV schema class, and basically I want to print the schema of a CSV file. So let's go into that class and see what it's doing. Okay, and that class is of course right here. So notice that this is going to create a Spark session, and using that Spark session, it's going to read the format of a CSV file. Okay, so it's expecting a CSV file. Now there are some various options here because this is a more complex CSV file than the code that you saw earlier. Okay, so let's open this up. This file is located in source main resources folder. So that's right here, and it's called Amazon products. Let's open that up. So this is a CSV file that actually goes on multiple lines. So this is first of all, these are the headers. Okay, so it has 1, 2, 3, 4, 5 columns, and then the first column contains the ID, and then the second column is the product ID, and the third column is basically the title, which is all of this. Okay, up to this point, and then the published date is right here, and the URL is right here. Now notice that this is not really a comma separated file. This is actually a semicolon separated file. Notice there's these semicolons that are separating the different data elements. Okay, so that's one major change from the previous version that we saw. So the title column contains all of this big text that spans 2 lines. Okay, and notice in the beginning there's this caret. This is known as a caret character, and towards the end of that text there's also a caret. So this actually represents, in this example, let's consider this to represent quotes. Okay, so you'll see that anywhere where you see this caret, we want to interpret this text as quotes. So this is a more complex version of a CSV file than we've seen before. So similar structure here, we create a data set with row, which is known as a data frame. Okay, and that is going to have the variable df to represent data frame, and we're doing a Spark read format CSV, and the option header is true. Then we set up another option which is called multi-line true, meaning that if the value of a given column is on multiple lines, we need to make sure that we do multi-line, because remember the title field could span multiple lines in this example as we saw. Okay, then the separator is not a comma, it's actually semicolon. Okay, so you can specify any separator that you want here. We know from the file that it's semicolon, so that option is available to us. We can also separate using tabs, pipes, and all other different characters. So a lot of flexibility here. Okay, the next thing is this quote property. So we're basically telling Spark that, hey, anytime you see this caret, consider that a quote. okay? We don't want this caret to show up in the data. This could have been any character, but anytime it sees that character, we can actually tell Spark that, hey, treat that as a quote. And that's what we're doing here. Then the date format option is also available to us. So now we're telling Spark that, hey, there's going to be a month, day, and year format, okay? So it's going to look for that for anywhere where it sees this kind of a date format. And then we are inferring the schema to be true. So we're not hard coding a schema or anything. We're telling Spark to figure out what the data types of some of these columns should be, okay? And I'll show you later how we can create our own schema, customize the schema for a given file. I'll show you how to do that. And then finally, the load option. You've seen this before, where we specify the location of where that file is. And then right here, we're just printing to the screen excerpt from the data frame content, and we want to show the first 7 rows, okay? And that's pretty much it. And then over here, df.printSchema. This is useful to be able to see how Spark interpreted the values in those columns. You know, what data types did it interpret those values as, okay? So that's what this print schema method does. And in the application class where we have the main method, we're creating an instance of that class, and we are executing the print schema method. So it'll execute all that code that we just went over. All right. So let's right click and run this application. Let me bring the console up a bit. Okay, so that finished executing. If you scroll a little bit up, you'll see that it says the data frame's schema is this. Okay, and it took the listing ID, the product ID, treated that as integer. Okay, it sees that those are numbers. The title, it's treating it as a string. So great, it's interpreting that. The published date, however, it's not treating that as string. Okay, it leaves that up to us to figure out whatever that data type is. It's not trying to be too smart. I'll show you how to treat this as a date column in just a moment. And then the URL is, of course, going to be a string as well. Okay, so this is being printed from the last portion of this method, which was right here, df.printSchema. That's what this is showing. Then this df.show7, this is actually going to show 7 records. So we only have 4 records in that file, so that's what this is going to show. And notice it was able to correctly parse those things out based on the semicolon separator. Okay, and the title, it contained the caret character in the beginning and the end, right? So we're not seeing that here. So it's treating that as quotes. If we were to get rid of this option, then it would show this caret symbol as part of the title. Now, if you wanted to see more characters for a given column, you can actually use the second option down here. I'm going to uncomment this line. Let's comment out df.show7. And let's do df.show790. This basically specifies how much of the field you want to see. So truncate after 90 characters. If we use this option, it truncates after, I think, 30 or 25 or so characters. We want to see more of each of these fields. Okay, so let's try the 90 option. So save this file and let's go back to the application class and run this class. Make sure when you're running, you're always here, because this is the file that contains our main method. I'm sure you're familiar with this already if you're a Java developer, which I hope you are. Okay, now that's done. Let's scroll up and notice now we see a lot more of each field. Okay, the title, it's showing a lot more, up to 90 characters. Okay, so this of course doesn't give as pleasant of a format in the display as it was before, but that's okay. We're changing the amount of characters that are displayed, so of course it's gonna shift things around and won't be as pretty as the default, but hopefully you get the idea. So now let's move on to the next example. I'm going to comment out this first example, and let's uncomment out this second example. Here we're actually, this is referring to a class called define CSV schema. So we can actually manually define the file's schema, okay? The previous class that we looked at, the infer CSV schema, we're not specifically giving any kind of names to these fields. These are coming raw from the file, and we're leaving it up to Spark to figure out what the data types of these columns should be, right? And it was pretty much smart enough to figure that stuff out on its own, but we can actually hard code the different data types for each of the columns, and that's what this class define CSV schema does. So let's open this class up. Here's that class. So the print defined schema method basically does the same thing, establishes a Spark session. And then there's this thing called struct type. Okay, this is a type that comes from, let's scroll up here. It comes from org.apache.spark.sql.types. Okay, and what that allows us to do is define our own data types. Okay, you can use this data types dot create struct type, and then you do new struct field, and then you specify an array containing all the fields that we are trying to define for the given schema. Okay, and we're titling this variable schema because that's exactly what this is. So the different struct fields are, the first one is ID. So instead of listing ID, I want it to just show ID. Okay, and the data type for that is integer. And this false value, we can take a look at what that means if we open up this method's definition. Notice the last argument here is whether we want it to be nullable or not. When you do nullable false, then it expects a value. So that's what we're specifying here, meaning that every value in a given field must exist. Now, in this example where we have the product ID, this is set to true, meaning that it is nullable. So if there is a product that doesn't have a product ID, that product will still be displayed because, we have set this to true. And same thing goes for this right here. Okay, for the published on. It's okay to not know the date at which this product listing was published. And then down here, this is a multi-line. We're specifying that a given field could be split onto 2 or 3 lines. So that's what this represents. Header is of course true. The separator is still semicolon. The date format is still the same. And we're considering these carets as quotes. Okay. And this is the key right here. The previous version where we had the infer schema class, that did not contain this line where it says schema. Over here, we're not inferring the schema automatically. We are giving it the schema that we created up here. All right, so we're tagging on this dot schema option down here. Okay, and then we're doing the familiar load method. Okay, so let's close this file, and we're creating an instance of that class, and we're running the print defined schema. So I should see a defined schema here. Similar to what Spark was able to create for us right here. So let's rerun this and you'll see the difference. Notice over here, it's saying published date is a string. But when I run this, you'll see that the published date is now being considered a date field. So let's right click, run as Java application. Okay, so that program completed. If you scroll a little bit up, notice this is our new schema. Okay, and the columns have now changed. Instead of listing ID or item ID or whatever it was, I just left it as ID. And then the product ID, item name, published on. These are the new columns that I defined in the schema. So it's registering those. And more importantly, the date column is now actually the date data type. Okay, so this is pretty cool. Scroll up and you'll see the breakdown here. Okay, the field names have changed since we changed them in the schema. So hopefully that's straightforward. The main thing to keep in mind is when you create a schema, let me go back to that define CSV schema class. When you create a schema like this using the struct type, you want to make sure that this schema variable that you define here, you tag that on using the dot schema method to the Spark reading function. All right. Just like the other options, we are basically just adding on a dot schema, and that's when Spark will be able to recognize that we have a hard-coded schema. Okay, so let's comment out this now and move on to the third example here. And this is not a CSV file. This is, as you can see by the name, a JSON line parser. So let's open this up and take a look at what it's doing. So this is actually straightforward. We're doing the same Spark session creation here. And then we have this spark.read.format JSON. Okay, instead of CSV, this is now JSON, and we're loading the JSON file from right here, which is simple.json. So let's open that up right here. This is that file. Okay, now it opened it up in my default text editor on this system, which is Sublime Text. For you, it may choose to open in Eclipse, doesn't matter, but as long as you can see this file. So each record here is on a different line. That's the key takeaway from this. This is known as a JSON line syntax, where the entire JSON is on one line and then the next JSON entry is on another line, and so on. Normally you would need an array with commas to separate the different JSON documents. But here we have 4 documents, 4 records, okay? And they're each being given their own line, okay? So let's close this file. So this first option here, we're creating a data frame for JSON, and we're loading this JSON, a simple JSON. The second example, I'm just gonna comment it out for now. I'll get back to that in just a moment. So this df, we're then gonna show the top 5 records. We only have 4 records in there, so it doesn't really matter. And we're showing up to 150 characters for each of the given fields. And we were also printing the schema. Now this is not gonna print as a JSON format. This is gonna print in the df.show format, which is going to be looking like this, like a table. So let's close this and run this. And by the way, to avoid all of the logging, it takes a lot of time to print all the logging messages. I'm skipping ahead in the video. It's not that my computer is super fast. I'm basically pausing and re-recording once the log entries are all printed out. So anyway, here is the schema that it was able to figure out. So this is the schema for a given record, and notice that it has a name and then the owns field, and this is an array of different elements. So let's take a look at the actual data. So here it is. This is a very simple document where we have the name for a given person. So first name here is Top. Don't know what kind of name that is, but it exists. And Top owns a car that is Honda and a laptop that is Dell. So notice the formatting here is a multi-dimensional array. Okay. In this array, we have 2 arrays. One of them has to do with one item, and the other array has to do with the other item that Top owns. And same thing goes for Frank and Peter and Samantha and so on. Peter here does not own anything, so we left that as an empty array. Okay, and you can check that in the JSON. Now a more complex JSON is right here, multi-line JSON file. Let me open that up. And notice in this example, this is known as a multi-line JSON, meaning a JSON document such as this entire thing that I'm highlighting here. This is known as a JSON document with the opening and closing curly braces. This entire document can split multiple lines, okay? And to separate one document from the other, there are commas. And all of the documents are surrounded with this array, open, close brackets, as you can see right here on top and bottom. Okay, so here is an example of 2 documents. So we're gonna leave it up to Spark to figure out how to parse that. Now let's go back to the JSON lines parser file real quick. So we cannot parse that file as simple.json like we did. Let me comment this out and uncomment out this portion right here. So this is actually the way this is different is, first of all, of course, it's referring to the other file, which is multiline.json, and then there's another property here which is multiline is equal to true. Okay, so we're tagging on this option to let Spark know that, hey, we're going to have documents that span multiple lines. Just like you saw in the CSV example, we also had to add a multi-line when the value of a given field splits or spills over to the next line. So this is important for this kind of a complex JSON document. Okay, in the simple.json, each line represented an entire JSON document. Here, that's not the case. So instead of df.show, it's going to be df2.show for this example. So let's save this file and let's right click and run the application class. And there we go, we're done. So if you scroll up, this is the schema definition. So you can actually go through the document yourself and see how this matches up with that. This is the correct schema definition, the way it's translated here. If you go back to the JSON file, you'll be able to see that the structure here matches the multi-line JSON file. Okay, so let's look at the actual table that this was able to construct for us. So there were 2 documents, so it recognized that, and then there's this column called building key. Geolocation is basically an array. It's a multi-field, so it has an array as well as this other value, and then in the properties there's an array as well as 2 other values. Okay, now notice that it's not actually giving the field names in the record that it's displaying here, and that is a normal way of Spark parsing your JSON documents. If you open up the multi-line JSON real quick, for example, the geolocation column, notice that it printed exact and it printed these 2 values. So exact has the field name called type. It's not displaying that in the table. And then these values that are an array, they belong to the coordinates field. It's not displaying the field name, all right? It just shows the values. Same thing goes for this field right here, latitude and longitude. This is just an array. So in the properties column, it won't say permit number. It'll just show this value, and it'll just show this array, okay? So let's go back to the file here. Notice it just gives the address. It doesn't show the field name here for latitude and longitude. And same thing goes for the geolocation field. Okay, so hopefully you get the idea. Nested fields are not printed in the record. Only their values are shown. And that's typically the most important thing in a JSON, right? You're usually dealing with the values, and you can access them through their field names, and we'll get into that later. So these were a few examples of how to parse different kinds of files. CSV file is a very common thing, and so is JSON. So you got the two most important techniques for parsing files. There's also XML files. XML is just getting so old, but you can actually parse XML the same way that you did the CSV or JSON. All you'd have to do is change the format. So instead of it saying JSON or CSV, you'd have to write XML here, and Spark will be able to read it in that format. All right, so this lecture was on ingestion of different types of files, ingesting into Spark. Well, we didn't talk too much about transforming these values, but we'll get into that pretty soon. So let's wrap up this lecture. Thanks for watching. I'll see you in the next one.